Hello! This is a problem I have been looking into before, and I just wanted to rewrite it from scratch and look to see how what I can learn from doing test-driven development on this example. Because I tried from the beginning, didn't do that much testing, just on certain issues, and multiple times stumbled on things that didn't go well or took too much time to debug. So for me, that sounds like a perfect place to use test and development. Also, after done this for a while, I figured out maybe this should be a library, and then I want to have tests so that others don't need to find bugs for me. What we're going to build today is a simplified version of KD Tree. KD trees you can look up on the internet, but basically it's a binary search tree that have more than one dimension. I'm gonna probably just do one dimension here and then try to refactor the code to be able to handle multiple dimensions. I have some things I want to implement. I want to be able to insert a key. I want to create from a list and destruct into a list. I want to be able to find smallest because I know that I need that to then be able to delete items in a nice fashion. And then of course I want to be able to find items, and I want to be able to find a key. I want to be able to find a range. I want to be able to have ranges as key and find overlapping regions with those when I'm looking for them. And I also have this idea that when I'm searching for more than one of something and return that, I want the result to be able to be a tree as well. I have my editor set up where it runs the tests on the right as soon as it detects a change. I have my two tabs set up. So I have the code and I have the test. The test and the code. Let's start by testing tree. What I want to be able to do is I want to be able to insert, and I'm thinking it inserts smaller values. It replaces empty trees with non-empty when inserting. This is not the best test name I ever created, but it's some place to start. We'll probably go back and fix this, but let's start with this. And we have an empty, and we do insert into this one. And I don't want to detect insert. Let's just be here first, and I want to insert a number 1, and I then want to say that it should be equal a tree of node empty 1 empty. So this is what it should do. I want to then create a insert k, and let's just return empty, and this should give the correct annotation for this, and we can help it and say that it's k. Okay, so I also want to add it to exposure list. I also know that this exposure list will be large, so let's format that and get back here and import it. I want to import it from KD. It has some issues. What's the issue? Type mismatch. Right. Yes, it also needs, of course, a KD tree. So let's tree and duplicate this. Format it, run it. Oh, it takes a long time. Okay, so let's just fake it until you make it. You would think I could now write node empty one empty. But the type here tells me, no, you can't do that, because I can't ensure that the tree here is a number tree. It could be anything that is k, because we have no restrictions on what k is. And this is a very interesting, you would think that because of generics, or in this case type variables, you would have a free world, but actually you add constraints, which is very interesting. So I could not really implement this wrong here from the aspect of the test. So I actually need to write this already. Okay, so we have fulfilled that test. Let's think about what's the next test that we could write and make a, that was not how it should do, like that, I think. What should we call this test? How does the code that we currently have tell us that we need to broaden the specification? I would say that inserts smaller values to the left is what I want to know, I want to have. So let's keep this. This is the one we want to insert, right? And we can have a 2, and we can have empty, and this is a node. So hopefully, thank you, or not so much. Let's see here. Sometimes the formatter helps you a little bit too much and actually ruins what you're doing, but I like it anyhow. Insert smaller values, not values. Okay, so you can see here that we have a tree. Let's do that and say empty here instead. So we have a tree that's non-empty, that contains a number 2, and we now insert a number 1, and we want to make sure that it puts in the right order. What we need to do here is say case tree, right? And we can, okay, let's do some refactoring first. So I want to put this as a value, and we call this value node. Okay, and we want to put the value node into the tree. So want to do a case on the tree of, and if it's empty, we know that we need to replace it. So that is cool. But the compiler or the editor here actually is complaining that we're missing this expression. And I'm gonna do smaller because I think it's easier to read, and we can do this that is larger. And we have a k here that seems like we should use it, but actually we're gonna just reuse them to be able to recreate the new thing, and we're gonna call this k1 and replace smaller with value node. And we can see here that we're not using smaller, which might be the direction we're now gonna create the test, so that we need to use smaller. But we also have this issue where we actually don't care about the k value. So I can see 2 tests written here to go forward, implementing the insert function into something more real. What I'm going to do then is duplicate this one, and we're going to do insert, let's do larger values to the right and put a 3 here and do empty 2, 3. So I think it's really hard to look at this data structure as code and see what it actually is doing. I think it's a little bit too large for this video, but I would definitely think about maybe doing approval testing techniques here and create a printer just to make it easier to read it. So let's see how hard that is to do, and we'll maybe refactoring test to use that. But I just want to focus on doing this. Okay, so now we actually have a if k1 is larger than if k is smaller than k1. Like, this is how you should write your if statements. You should have the smallest value to the left and then do smaller than, because that's how we think. We usually have small things to the left. Then do this one. Else, and now you see here, we need to use this one. We also see that we will need to have a restriction on the value k. And the reason for this is that let's remove that and ask it to add the type notation. Yeah, you need to have a specific name for types in Elm code that you can compare. So beforehand it was called k, now it needs to be called comparable because we compare it. And this is a lazy way out to not implement type classes that you have like in Haskell and stuff like that. So there are some type classes-ish in Elm that you can't extend, that's built into the language, and this is one of them. Okay, so we look at the code, we think, what is wrong with this code? We always discard the whole subtree of something. So let's create a test that says test it does don't discard subtrees, insert into them. Again, probably a better way to word this, but you get the message across, and we'll think about names later. It's good to think about being honest and then be correct. Give it a name at all is better than no name, or taking too long to think. Everything here has to do with insert. So I'm gonna actually move this, sorry, that was wrong parentheses, here and say describe insert. We now want to have a node that is 2. We can take this tree. So we have a node here. That is in the left side, and that is smaller. We want it to be a very unbalanced tree, but that's okay. We're not thinking about balancing right now. And that one should have a 1 in it. And maybe we can even get a good error reporting here. Not that great. We can see here that it's at least missing the 2. Let's implement this, and then we can stop the video and create a new one for the next challenge. So if we do a case no, this is the one here, sorry. Case of smaller empty. So this is the case we already implemented. implemented. This is the case we haven't. And we actually don't care about what it contains here. We just want to say, okay, if it's not empty, we need to insert into that one. So node insert k into smaller, and then k1, and then larger. So that worked. And we just need to do a test case for the large case. Let's do that one quickly as well. So we do that by doing a all here. So all in this testing tool says, okay, all these tests needs to pass. All these tests need to pass in order for this test to work. So all these conditions need to be true. And if you want, you can pass a common parameter to both of them. In this case, it's gonna have nothing. I'm gonna make this empty. I'm gonna give this a 3, this a 2, this a 4, maybe? And I'm gonna put here a the right error. We're gonna do a case of larger. We have already the empty case, and we're gonna add the missing, and we really don't care. We just care that it's non-empty, and then do insert k in larger. While doing this, I realized we probably don't need to do inner cases, but I'm not sure. Now I made it work, and it wasn't hard. Like, it took some typing, but it's not typing that takes time, actually. It's thinking, and for me talking to you as well. So I want to try out and say that maybe the only thing we need is actually this one. Does this suffice as the code? And it did. So then I want to simplify even more. Okay, it might be that I missed something here. I need to inline this. Let's do it by hand, because it's not used in the other branches, so I don't want to create it if I don't use it, because Elm is not lazy as Haskell. Now, as a programmer, I need to think, is there something here that I haven't tested? Is there something this code does wrong, which I need to have an example of? And I don't think it is. I don't think there is. Well, I'm quite happy with that. So I'm gonna just commit it and say implement insert for KD Tree. Cool. Okay, see you in the next session.